Welcome back everyone. So today we're going to be doing limiting values, but just before that, just a couple of terms I want to make clear first. So a diverging sequence is when you have a sequence that will just continue to get bigger forever. So if we take 2n as an example, I'll just write the first 5 terms out. So what we see here is that as n increases, so does the value, and what we call that is n tending to infinity, which is written like this. And so, as we're going to see in a few minutes, some of the questions will be phrased like, what is the limiting value as n tends to infinity? And keep in mind, this applies to negative numbers as well. So take minus 5n. So although literally it is getting smaller because obviously it's negative, we still say that this is a diverging sequence because it's essentially it's going further away from zero as n tends towards infinity. So on the other hand, you have converging sequences, which are sequences that don't go off to infinity, but they actually tend to a specific value. So a good example of this would probably be 1 over 2 to the power of n. Now this can be written a bit nicer because it can be written as half to the power of n, so I'm going to do that. And as we're going to see when I write out the first 5 terms, it's going to tend towards 0, not to, plus or minus infinity. So I've also decided to be nice and write it as a decimal if somehow that helps you visualize it better. And as we can see, the decimals they get a bit complicated, but the main thing to note is that they are getting closer and closer to zero, which you also need to remember, right? They're never actually going to reach zero, but they're always headed in that direction in this instance. So what this means is that as n tends towards infinity, the limiting value is zero in this instance. So we've got this question here, and at first it might look a little bit complicated, but I'm actually going to explain why it's really not. So the nth term of the sequence is 4n squared minus 6n plus 7 over 2n squared plus 18. Write down the limiting value as n tends to infinity. What we do here is we identify what the biggest power of n is. So we see here it's the n squared, and we literally ignore everything else. So minus 6n plus 7, get it out of here, plus 18, don't care. So now we just have 4n squared over 2n squared. And what we do is we take the coefficient of what's before it, so it's literally just the 4 and the 2 we're interested in, and we divide it like so. And literally, that's all you have to do. 2 is your limiting value. We've got another question here, and we're going to do the exact same thing. So what is the biggest power of n? We see that it's the n cubed over here. So minus 75, get it out of here, plus 25n, get it out of here. And so now we're just focused on the biggest power. And another way to write this is literally just 1 over 5. That's your limiting value. So hopefully you can see these questions they're fairly straightforward, but obviously you just have to pay attention just to avoid any little mistakes. Alright, so this question here is a little bit different, but in my opinion, it's actually different in a way that makes it even easier. So if we identify the biggest power, we can see that it's n squared. So we're going to cross out anything that's not n squared. And what you may have noticed is we've eliminated the entire top row. So that's going to be 0. And 0 divided by literally anything just gives you 0 again. So already that is your limiting value. Here we have a slightly different problem, and as the title says, this is for when we actually know the limiting value. So we're told here it's 5, and obviously we're told the nth term. So we're going to go about this in a similar way. We're just going to identify that n squared is the biggest power, and we can ignore everything else. And so we know that an squared over 8n squared is going to be 5. And I'm just going to remove the n squared just to make it nicer. And from here, you can just tell that a is 40, and that will be your answer. This one's a little bit more complicated, but we're going to go about it in just the same way. So we're going to see that the highest power for both of these is n cubed. Ignore everything else. And so from this, we can gather that minus an cubed over 10n cubed is equal to minus 2/5. And like last time, I'm just going to take away the n cubed. So now that we've got to this point, what I will point out is that minus 2/5 can also be written as minus 2 over 5. So we have it like this. And then at this point, we want to get minus a on its own. So we're going to multiply both sides by 10. And obviously, minus 2 over 5 times 10 is going to give you minus 4. And now that we're in this position, we can literally just flip the signs on both sides and it will give us the answer. And just like that, you found the value of a. So I would say this type of question, which I did steal directly from OneNote, is probably the most difficult that you can find on this topic. But I'm just going to write this sequence out a little bit bigger just so it's easier to work with. So for now, what we have to do is we actually have to treat the numerator and the denominator as completely different sequences. So we can see that from 4 to 7 is plus 3. So we know that it's going to be 3n up here. And obviously to get from 3 to 4, you just add 1. So we found the nth term of the numerator sequence. Now we're going to do the same for the denominator sequence, and we're going to see 3 to 5 is plus 2. And again, 2 to 3, you just have to add 1 on, so it's going to be 2n plus 1 over here. And now we almost put them back together, if you will, and we see that the sequence here is 3n plus 1 over 2n plus 1. And now we do what we've been going over today, and we just see that n, which is actually disguised as n to the power of 1, okay, remember that, is the largest power here. So we can ignore these plus 1s, and we can see that this just resolves to be 3 over 2. So there's your limiting value. So just to clarify, this over here, including the plus 1, will be your nth term, but over here is your limiting value. So like I said, this type of question is probably the most difficult you can get on this topic. So if you understand this, as well as all the other stuff I've been over in the video, then you should do pretty well in an exam if you get asked about this.